Okay, so this is a video covering some SAT math practice problems that my student was having questions about, and this section has to do with ratios and units. So we're going to go ahead and just dive in. Mike's bank account contained $1,000 in 2013. Exactly 4 years later, in 2017, the same account contained $2,056. If the amount of money in Mike's bank account is increased by C dollars every 5 months, where C is a constant, what's the value of C? Okay, so apparently um, his bank account increased by C dollars every 5 months. Okay, so I'm going to imagine that we could set up this sort of relationship where it's dollars over months. And that's the relationship they mentioned towards the end. We know that Mike's bank account increased C dollars every 5 months. So this is a relationship that's true if we take into account the units of dollars and the units of months. So if we want to find out what C is, it might be a good idea to set this fraction C over 5 equal to some other fraction that would feature dollars on top and months down below. So one way of going about it is by recognizing that according to the problem, in 4 years, from 2013 all the way up to 2017, in 4 years, the monetary amount increased from 1,000 to 2,056. Okay, so that took place in 4 years. Now let's think about 4 years, from 2013 to 2017. Isn't it true that there are 12 months in a year? So therefore, there would be 48 months in 4 years. So I'll say that again. There are 12 months in 1 year. So imagine this is a year, and there are 12 months, in a year. These are all the months inside that 1 year. So how many months would there be in 4 years? Well, there would be 12 times 4, right? Which is 48. So I'll actually draw them all. These are all the months. Notice how I'm dividing each by 4, and then dividing these little intervals by 3. So if you were to count all these, it would be 48 months. Now, at the end of the day, do you have to draw this? Absolutely not. At a certain point, after a certain amount of practice, you would realize, okay, 12 months in 1 year, therefore there are going to be 12 times 4 months in 4 years, which is 48 months. So the point is with that is that you could write 48 months down here because according to the structure, we want months down below. And we could acknowledge the fact that there was a certain monetary amount, there was a certain dollar amount associated with 48 months gone by. And in this case, it would be this 2056 minus 1,000. 2056 minus 1,000 would be 1,056. So that's how many dollars were made, I guess, in the account in 48 months. Okay, that's the dollar increase in 48 months. So what you're going to want to do in this case is just use the proportion. What you have here is a fraction set equal to another fraction. And whenever you have a fraction set equal to another fraction, one of the things you could do is certainly cross multiply. However, I'm a fan of saving time if it's possible to save time. And in this case, it is possible to save time. At the end of the day, we just want to solve for C. And the only thing in the way of C being completely by itself on the right is this 5 right here. So what we could do is we could get rid of that 5 by multiplying both sides by 5. That would cancel out the 5's. And that would leave us with C equals 5 times 1056 divided by 48, and that is 110. Now you do want to be careful when you're multiplying 5 times this fraction. It's important to recognize that the 5 has a secret denominator of 1, so you could think of it as a fraction times another fraction if you wanted to. And in the case of a fraction times another fraction, you could always just multiply straight across. 5 times 1056 up top, 1 times 48 down below. Then you'd have some large number up top divided by 48, and that would give you 110. Hopefully that makes sense. Okay, so for the next problem, an ecologist calculates that a certain forest is growing at a rate of 2 3/5 of an acre every 2 years. Based on this ecologist calculation, how many years will it take for this forest to grow 39 acres? Well, this is another case where a proportion would be a decent way to go. And we could have acres over years. And since we're going to do it that way, it would be 2 3/5 of an acre all over 2 years, because that's the first piece of information they give us. And then we could set that equal to X years corresponding with 39 acres. Okay, how many years will it take for this forest to grow 39 acres? So the acres goes up top, and the X years would be down below. Now, in this case, I actually would cross multiply. But before cross multiplying, it's probably going to be a good idea to, at the very least, change this to an improper fraction. We don't want to be working with mixed numbers in the midst of the process. We could always have a mixed number as the final answer, or a mixed number in the beginning of the problem. But typically when you're working through a mathematical process, you're not going to want mixed numbers. So I would convert 2 3/5 to an improper fraction. As you may recall, that would be a matter of 5 times 2, which is 10, plus 3, which is 13. So we would have 13 over 5. And we're just going to kind of get rid of that. Now, we have a fraction over a whole number. There's actually more we could do to simplify this, but I'm just going to go for it right now and cross multiply. 13 over 5 times x is going to be 13 over 5x, and that's going to equal 39 times 2. 39 times 2 is 60 plus 18, also known as 78. Now, we have a fractional coefficient and a variable that we're trying to solve for. One trick of the trade, if you want to solve for that variable x and it has a fractional coefficient, is you could multiply both sides by the reciprocal. And in doing so, these would cancel, the 5's would cancel, leaving us with just x equals 78 times 5 divided by 13. Once again, if you need to remember, there's that invisible 1 underneath the 78, and you could, if you wanted to, multiply straight across. There's also a possibility that there could be a cross cancellation here as well, but I don't know if there is, so I'm going to go ahead and just use my calculator. 78 times 5 divided by 13, and let's find out what that is. Okay, so that turns out to be 30. So there probably was a cross cancellation that could have taken place there. So good stuff. I guess 13 times 6 would give us 78. So x equals 30. In other words, it would take 30 years for there to be 39 acres. So hopefully that process makes sense. Jim walks 18 feet in 13.9 seconds. At this rate, how many feet will he walk in 2 hours? So once again, proportion will probably be to the rescue in this case. So we're going to have feet per second. Now, apparently, the first piece of information would relate 18 feet to 13.9 seconds, and we can set that equal to another fraction. Now, they want to know how many feet will he walk in a certain amount of time, so it's x up here because we want to find out the distance traveled here. But they mentioned 2 hours, though. So the question is, how many seconds are in 2 hours? Because we're dealing with seconds, right? We're not dealing with hours. We're dealing with seconds. So we want to find out how many seconds are in 2 hours, and we're going to put that down here, okay? Now, one way of going about this is to do a unit conversion. So we could put 2 hours here. And we know we don't want the word hours in the final unit conversion. So we're going to force the word hours to be down here, and we're going to associate that with another unit of time. Now, we know that 1 hour corresponds with 60 minutes. But the problem is we don't want the word minutes here either, so we're going to have to force the word minutes down here. Now, for those of you new to this sort of unit conversion process, just understand we're trying to convert 2 hours to a certain amount of seconds. Therefore, in the final sort of answer, we're not going to want the word hour, so we're setting up a situation where we put the word hour down here diagonally because they're going to cancel soon. Not necessarily the numbers, but actually the literal words themselves are going to cancel. And we're going to have to do the same thing with minutes, okay? We know that in 1 hour there's 60 minutes, but at the end of the day, we're not going to want the word minutes in the final answer. So we're going to put the word minutes down here. And then we can remember, oh, there's 60 seconds in 1 minute. So every time there's 1 minute, that corresponds with 60 seconds. And at that point, you now have the word that you're looking for. And we've constructed this sort of diagonal situation such that the words we don't want are going to cancel. So let's go ahead and cancel the words hours and then minutes. And at that point, you just treat everything like a fraction and multiply straight across. Now, 1 times 1 is just 1, so we don't have to worry about that. But when we multiply the top straight across, that's going to be, looks like it's 7,200. Okay, 7,200. So that's how many seconds are in 2 hours. So that would belong down here. Because once again, we are dealing with a proportion featuring the units of feet and seconds. So at this point, I think most of you would recognize that we could certainly take this proportion and cross multiply. There's no question about it. However, I'm a fan of saving time. So rather than cross multiply, I'm going to say, let's go ahead and simply multiply both sides by 7,200, because that would immediately get the x to be by itself. Now in doing so, these would cancel. We'll do a little divider here. We're going to end up with x by itself. But then the question is, what's 7,200 times 18 divided by 13.9? Well, that would be 9,323.741 approximately. And let's remember that in the problem, they asked us to round the answer to the nearest whole number. So we're going to put these approximation symbols. That's going to be 9,324 feet. So that's the answer. Hopefully that makes sense. In a different galaxy, aliens use a unit of weight called a snark, which is equivalent to 14.1 ounces. Those aliens also use a larger unit called a blurg, which is composed of 7 of those. Based on these relationships, 30 blurgs is related is equivalent to approximately how many pounds. So in other words, we want to find out 30 blurgs, how many pounds? All right, 30 blurgs go with how many pounds? So let's just recognize, of course, it's a weird problem. I mean, they're giving you weird concepts that you've never heard before. They're making up stuff. But it's important to really focus on the final question. And the final question is just asking, okay, 30 of these is equivalent to how many pounds? That gives you a sense of what proportion to set up. Clearly, we're going to be dealing with blurgs over pounds. So I'm actually going to write that. I'm going to write blurgs over pounds in the same way that we've kind of done before. And we know that one of the fractions is going to be 30 over x, but the question is, what is the other fraction we're going to set it equal to, keeping in mind that we have blurgs and pounds down there. So this is an example of a problem where it might not be completely clear what to do in order to find another fraction, but we want to use the previous information to perhaps even stumble upon some other fraction that would feature blurgs related to pounds, okay? So I'm going to go ahead and recognize that ultimately we want the word blurgs up top because we're going to try to construct a fraction that has blurgs up top and pounds down below. So we put the word blurgs up top and take it from there, you know? Let's just see what happens here. So we have the fact that a blurg is equal to 7 snarks. So I'm going to actually write 1 blurg corresponds with 7 of these things. Now we don't want the word snark in there. So we're going to write snark up here because we're going to want that word to cancel. So let's see if there's another relationship we could set up over here. Apparently, 1 snark is 14.1 ounces. So I'm just going to set that up. 14.1 ounces. Now, I already can see that the word snarks are going to cancel, and blurg is up top where we want it to be. We're going to want the word ounces to cancel, so I'm going to immediately put the word ounce up here and search for another relationship. Well, apparently, every 16 ounces corresponds with 1 pound. So we could write that relationship, 16 ounces corresponds with 1 pound. Well, at that point, we have the 2 words that we want because we're trying to find some kind of a fraction that can relate blurgs to pounds and just put it over here, and then we're going to solve for x by cross multiplying. Well, it actually looks like we're about to do that because we force the word blurgs to be up top, and we set up a chain of relationships that would leave the word pounds down below, LB. So we're going to go on that mission now. Going to cancel out the word snarks and ounces. We're going to treat each of these like they're fractions, and we will be multiplying straight across. And when we multiply straight across, we're going to have, looks like it's 1 times 16, which is 16 blurgs. And down below, we're going to have 7 times 1, 14.1 times 1, and that's going to be 98.7 pounds. So what we've accomplished here is we've discovered a relationship between blurgs and pounds. For every 16 blurgs, there are 98.7 pounds, and that is most definitely the numbers we could put here. We could have 16 up top and 98.7 down below. So I'm going to try it. And then at that point, we can cross multiply. So in doing so, we would have 16 times x equals 30 times 98.7, which is 2961, also known as 2,961. Dividing both sides by 16 would give us 185, approximately 185. So I'll actually get rid of these and use the approximation symbols. And that should be allowed because they did ask approximately how many pounds. So what we've learned is that 16 blurgs corresponds with 98.7 pounds, which means that 30 blurgs has to correspond with 185 pounds. And in a way that kind of makes sense because 16 is very close to 15, and 15 times 2 would give us 30. So we want some number that is such that when you multiply 98.7 times 2, you're going to get that. And 98.7 times 2 is approximately 185, or close to 185 at least. So even logically, it sort of makes sense. So that's how you do that one. So the answer to this problem is A. Okay, a local concert venue can hold up to 1,200 people. The cost to put on a concert at the venue is $24,000, regardless of the number of people who attend. If the event organizers expect to sell only 85% of the tickets to a certain concert at the venue, what is the minimum amount they should charge per ticket so that they at least cover the cost of the concert? Well, the event organizers expect to sell only 85% of the tickets. So it would probably be a good idea to find out, okay, well, what number is that? 85% of the tickets. Well, the total amount of tickets that they would be willing to sell or able to sell is 1,200 tickets because the concert venue holds up to 1,200 people. So the question is, therefore, what is 85% of 1,200? So in my opinion, that's actually a decent place to begin. You could find out what is 85% of 1,200. And you could figure that out by converting 85 to 0.85, converting the word of to, whoops, you could convert the word of to multiplying. I'll use an asterisk. And then we have 1,200. And 0.85 times 1,200 is 1,020. Okay. So that's how many tickets they can sell. And they want to sell, this amount of tickets for a certain cost per ticket so that they could at least cover the cost of the concert, and the cost of the concert is $24,000. Okay. So let's just think about it. If they want to at least cover the cost of the concert, let's find out the price per ticket they would need to charge in order to cover exactly 24,000, right? We're sort of imagining a scenario where they sell a whole bunch of tickets at a certain price and they make exactly $24,000, which covers the cost of the concert. They don't make more than $24,000. So in other words, they don't make a profit, but they could at least cover the cost of the concert. So I'm going to say, let's go ahead and set an equation up where it would be tickets, times the price per ticket. And that's going to equal, hopefully 24,000, right? And it turns out we already know how many tickets we're going to be selling. It's going to be 1,020, also known as 85% of the total possible tickets. So it will be 1,020 tickets times the price. Now that's actually what we're trying to find out. We're trying to find out what price should each ticket be, uh, so that we can actually cover this cost of 24,000. So I'm going to use P as the variable. So it's going to be 1020 P equals 24,000. And at that point, you can divide both sides by 1020. And of course, that would cancel those. And then we have P equals 23.529,411. And it goes on into decimal land. So that's what we get when we divide both sides by 1020, and we're dealing with price, so we're dealing with dollars and cents. So it makes sense to set this approximately equal to 23.53. And just to be super precise with what I write down, I should probably write this as well. Okay, so the price should be $23.53, which corresponds with answer choice D. A groundskeeper at a football stadium buys grass seed for the field. One bag of seed can plant 1/5 of the field with grass. If a football field is approximately 1 1/3 acres, how many acres can be planted with 72 bags of seed? So let's put the bags up top, and we'll put acres down below. Doesn't really matter. We could have done it in reverse, but I kind of like the idea of bags per acre. So we want to know, if we planted 72 bags of seeds, how many acres would that correspond with? So we'll call that X. And then once again, we're going to want to set this equal to some other fraction that would relate bags to acres. Because if we had a number here and a number here, then of course we could cross multiply. So our goal is to relate bags to acres somehow. So I'm going to have the word bags up here. And we're going to set up that sort of unit conversion chain scenario. And we're going to look at the clues that they give us. Okay, one bag of seed can plant 1/5 of a field. Okay, so I'm going to write one bag and 1/5 field. Okay, now we want the word bag to be left over after this whole process, because we want bags up top and we want the word acres down below. So I'm going to write a little box around it, because we're going to remember that we're going to want to keep that. We don't want to keep this though, so we're going to have to get rid of the word field. So I'm going to write field up here and ask myself, is there a way to relate fields to something else in the problem? Well, apparently a football field is 1 1/3 acres, so that's fine. So we have one field is 1 1/3 acres. Well, this is great, because now we actually have the words that we want. We have bags up top, and acres down below. So that's a good sign. We're actually getting closer to the answer. Now, some of you may have noticed we have a couple problems. This fraction's okay. I mean, we could deal with that. That's fine. It's really this 1 1/3 that's a little bit of a problem. I say let's turn that into an improper fraction. Hopefully at home you remember that would be a matter of multiplying 3 times 1, which is 3, and then adding 1, which is 4, and therefore the whole thing would become 4/3. So 4/3. And at this point we are prepared to just multiply straight across. We can definitely do that. And by doing so, we would end up with 1. Well, actually, we should cancel these words. My bad. Sorry about that. So we're going to end up with 1 bag for every, and when you multiply 1/5 times 4/3, that would be 4 over 15, 4/15 of an acre. Okay. Now that's a weird situation, I understand, because it's like 1 over a fraction. Okay, fine, I guess. But the good news is it's true. That's the good news is, even if it's weird, it's still true. Basically, what we've learned is that if you had 1 bag of seed, you could, um, plant 4/15 of an acre. That's what we learned. So we're going to write that information up here. So it's going to be 1 up top and 4 over 15 down below. And when we cross multiply, we're going to get x equals whatever 4/15 times 72 is. So I'm going to write that. 4 over 15, I'll wrap it in parentheses, times 72. I'll keep that in parentheses as well. So as you can see, we're actually really close to the answer. In a sense, by just doing that single cross multiplication move, we immediately have x by itself, and all we have to do is multiply these two things together. So the question is, what is 72 times 4 divided by 15? So when you plug that into your calculator, that becomes 19.2. So they want to the nearest tenth of an acre, and we already have that. So it's 19.2 acres. Okay, a bus traveled 4 miles in 14 minutes to the nearest tenth. What was the bus's average speed in meters per second? So ultimately, we want meters per second. So I think with this one, we can immediately just set up that unit conversion structure. We want it to be meters per second. So I'm going to force the word meters to be up here. I'll just use M for meters. Okay. And we're going to want to keep that word up there. And ultimately, we're going to want the word seconds down below, somewhere over there. But, we're not quite there yet. We have to set up this train of relationships. Now, the bus travels 4 miles in 14 minutes. That's certainly going to come into play. One thing we know for sure is that there's 1,609 meters for every 1 mile. I'll write MI for miles. Now, ultimately, we want meters per second, so we're not going to want the word miles here. So we're going to sort of force the word miles to be up here and ask ourselves, okay, is there another relation between miles and something else given in the problem? Well, yes, apparently there's 4 miles for every 14 minutes, okay? So I'm going to write that. There's 4 miles for every 14 minutes. Now, we're on the right track because the words miles will cancel. But we're also going to want this word minutes to cancel with the word minutes because ultimately we want only the word meters and the word seconds down here. Now, there is a final relationship we could set up where we immediately force the word minute to be up here so that it will cancel with that one down below. And we could recognize that 1 minute is equal to 60 seconds. And in that moment, we have meters and we have seconds. So ultimately, they want to know what's the bus's average speed in meters per second. Well, we force the word meters to be at the top. We set up this train such that meters will be at the top and the word seconds will be down below. And we also ensured that we put the word miles here, minutes here, so that the words themselves cancel. So miles is going to cancel with that miles, minutes is going to cancel with that minute. And then, as usual, you treat all of these as fractions, and you can just multiply straight across. So 1,609 times 4 is 6,436. 6,436. And then the question is 14 times 60 is, well, I'm just going to do this in my head. I'm going to do 14 times 6 in my head, and then I'm going to tack a 0 on at the end. So for those of you who like mental math, this is one way of going about it. 10 times 6 is 60. 4 times 6 is 24. 60 plus 24 is 84, and then we're going to tack on that extra 0. So it's going to be 840. All right, so that's a mental math way of going about it. And that's meters per second. So this is good to know. And in fact, this is the answer, except we're going to want to either reduce or just simply simplify that. They did ask to the nearest tenth. So what that tells me is you can go ahead and plug this into your calculator. It's probably going to give you some weird decimal, and that's going to be your answer after rounding it to the nearest tenth. So this I will plug into my calculator. 6436 divided by 840 is 7.6. It's really 7.66, but they want to round it to the nearest tenth, so we're going to do 7.7, and it's still meters per second. Okay, so that's an example of how you would do this one. Now, tying it all together with regards to the various problems that we just faced, problem, I think it was 9 through 15. Really, there were two main tools that you could use. There's the whole tool of using a proportion set equal to, some fraction. Like a proportion is when a fraction set equal to a fraction. And you always want to be clear what the variables are. For example, maybe this is seed and this is acres, right? I would always get clear about these first, and then I would construct it. The final question of each of these problems has often helped us see what this fraction is going to be, but then we had to go and use the other strategy, which is to use a unit conversion train, which, looks like this, where it's like blah, 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 all these numbers could look something like that, where you have a word here that you want and a word down here that you want, but you have all these other red words that you want to cancel out. So I'm kind of using this symbolism here to say these are the words that you'd have to cancel out, and the blue little things here are the words that you'd want to keep. In this case, maybe it's seeds over acres. But these are the two tools that you've needed so far to solve any of these problems. Some of the problems required only using a proportion. Some of the problems required only using the unit conversion train, which is what we just did. But unfortunately, some of the problems required that we used both. And again, that was often a matter of getting clear on the variables that the final question is asking for, constructing the unknown with some other number based on the positioning of the variables, and setting that equal to some other fraction that hopefully equals seeds and acres, that has seeds up top, acres down below. And in order to find this numerical relationship between seeds and acres, we had to use all the clues in the problem and go through this unit conversion train to figure it out. So when it comes to units and ratios on the SAT, these are fantastic tools that you can use for these problems. Okay, so hopefully that's helpful. Nothing replaces actually practicing these problems, right? Picking up some kind of a supplemental book and practicing, because to understand it by watching my videos is definitely not going to be enough. I mean, it could provide you with insight. It could provide you perhaps even with a different way of going about these problems. But unless you actually pick up a book and practice it, it's not going to stick, of course. But anyway, that's it for today. Hopefully that was helpful, and I will talk to you later.